Hey, welcome back. Alright, we have started this video from about 2 videos ago. Yeah, so here is the third video, the third part. We've talked about the introduction, the introductory part of the video. We mentioned Numpy. We talked about what array is in the first video. We also went through how to create Numpy, how to access the elements or the entries in a Numpy array, and now my focus will be on applying some conditional or conditions to access the elements in it. So we want to see how the Boolean array indexing helps in getting some elements from a Numpy array. So Boolean array indexing lets you pick out a selection of elements from an array. This type of indexing is often used to select the elements of an array which satisfy a specific condition, and the syntax is given below. Alright, so you call the Numpy array and the condition in a square bracket. So here's an example. We are interested in selecting all the values greater than 90 in an array. So all you need to do is state your condition within a square bracket just after the title or the name of the array. Don't forget that we've been working with the ratings array, right? So now I want to pick all the values in the rating array that are greater than 90. So once you put the condition in the square bracket and you run this cell, shift enter, you get the values that are greater than 90. Can you see that? Isn't this awesome? Of course it is. Alright, now let's talk about modifying Numpy arrays. First of all, we'll learn how to add elements, and the append methods are just as we've seen how to use it in Python list, also works just fine and similar way. We want to add an extra row, okay, to the array. So I'll call this ratings underscore extra underscore row equal to mp.append. You state the name of the array you want to append, the list or the row, and then you put the row as a list. So whatever you're appending inside or into an array has to be a list. Alright, but here, because we are appending just one single row, we have just a single row in the list. Okay, so I know why I'm stating this clearly. It's because you have 2 square brackets. So the first square bracket is the list that contains all the intended lists to be added to the array. But here I just have one single element in the list, which is also a list. Okay, and this list will be the additional row that will be appended to the array called ratings. And axis equals 0 lets you specify that this one to be added to the row. Okay, if you don't put axis equals 0, then Numpy will attempt to append that to the column. Let's run this cell and see what this gives us. As you can see, an additional row has been added. We now have, from a 3x3 array, we have a 4x3 array. Now, how do we remove elements from an array? Okay, we use the delete keyword or the delete method to remove elements from an array. Now, I want to take out the third row. Alright, don't forget, indexing starts from 0. 0, 1, 2, and that is the third row, right? We state the name of the array which you intend to take the row out. Then you put the index of the row in a square bracket also, and state axis equals 0. Once you run this cell, it takes out the array, the elements in the third row. Don't forget that we're not working with this particular array. The array I called here is the ratings array and not the ratings extra row. If I have called the ratings extra row, then the output from the output we should still have 3 rows. Alright, but because originally the ratings array has 3 rows, okay, and so when you call it, it gives you 2 rows because 1 row has been deleted. Okay, great. Now how do we use functions on Numpy arrays? There are several functions that can be operated on, or that can be applied to the elements in Numpy array. Here are a few of them. Numpy np.array.sum, we have .min, .max, and so on and so forth. Now in all these functions we pass in arguments, okay, and it allows us to perform the sum or whatever of the aggregations we want to take applied to separate rows. So if we intend to sum all the elements in the array, all we need to do is to say .sum, call the array ratings.sum, to sum up all the elements in the array. So it has added all the elements in the array, okay. And if you look at this, to add the elements row wise, you want to add the elements row wise, that is sum of each row, you have to add one argument in the sum method or sum function, axis equals 1. With axis equals 1, you are able to take the sum of all the elements in the row. So before we go ahead, I think I need you to understand what is going on here. Let's display our ratings, the ratings Numpy ratings arrays again. Now this is the ratings array, okay. So adding the elements in each row means we are adding 98 plus 89 plus 63. So I'm going to do it manually here for you to see, and then we'll confirm each of the entry in the sum output that we got there. So let's add 98 plus 89 plus 63. Once I run this cell, we have 246. That's exactly what we have here. That is the sum of the elements in the first row. To add the elements in the second row, we have 93 plus 92 plus 48, and that gives the sum of the elements in the second row, which is what, 233, and so on. Okay, so by just calling the ratings.sum and then you state the axis equals 1, it takes the sum of all the elements in the row. Now, but when you change, alright, before we go ahead, before I talk about changing the number 1 to 0 in the axis attribute, let's look at the main function. The main function displays or returns the minimum value for each row because you specify axis equals 0. But when we call the ratings of mean without specifying the attribute axis equals 0, then what we should expect to have is the minimum value amongst all the entry in the array. So here it returns 48, which means 48 is the least value in the entire array, which is actually true when you inspect here. But by specifying the attribute axis equals 1, we have the least element of each row. The least element of each row. Row 1 has the least element 63, row 2 has 48, and row 3 has 56. If your interest is to perform your aggregation column wise, then you state the attribute axis equals 0. With axis equals 0, you have the maximum of each entry in the row for each row, the maximum of each row. We have 98, 98, 63. When you inspect it, in the first, for each column, I mean to say, in the first column the maximum is 98, in the second column the maximum is 98, and the third column the maximum is 63, just as we've seen right here from our outputs. Okay, before I end this video, let's talk about when to use NumPy array. So when is the best time or best situation or condition that would enable or allow us to use NumPy array? A NumPy array is a data structure which stores multiple values, all of the same data type, just like I said earlier, and can be multi-dimensional. We should use a NumPy array if all of the following statements hold. 1. If we have multi-dimensional data, and all entries are of the same type, then NumPy array is the best data structure for that kind of scenario. NumPy array are also preferred over list of lists due to efficiency and functionality. So whenever you're dealing with nested lists, but in the case where all the elements are of the same data type, then it's better you use NumPy array to store that kind of data set. I hope this video has been very, very interesting, educating, and insightful. Please, if you enjoyed this video, kindly hit the like button to like the video. Feel free to share it with your friends and your colleagues. And if you're yet to subscribe to the YouTube channel, please go ahead and hit the subscribe button. It won't cost you additional data. Alright, thank you very much. And to those of you who are Datafied Academy students, we say thank you for choosing the Datafied Academy. I'll see you again in the next video, where I'll be introducing you to the second package, Pandas in Python. Do have a wonderful time. Until we see you again, bye bye.